Gary, can you tell us a little bit about the logistics of the project? You were mentioning that you were getting it from Store Renzo, and then a pandemic hit, which I'm sure you predicted before you got into this project, and you put in costing for it and all of that.
Obviously. So, primarily I store Enzo from the Ybbs mill in Austria, Germany, German border, are supplying the CLT. VHAG in Alfheim in Austria supplying the glulam, and Rothoblast supplying the screws, fortunately mainly out of Taiwan. So three main suppliers. The design period kicked off in earnest last July with a kind of three-staged approach to the design: engineering, first drop of GAs, second drop of GAs, sign off, and then we've moved into the the traditional IFC file production model stuff. Everything passed through to the manufacturers round about the end of November, ready to commence manufacturing in December, ready for shipping middle of January, ready for installation the end of March was our initial program. We have roughly 400 containers coming. The project is split into a number of zones. We've actually split the project into 9 zones. Each delivery is split into levels 1, 2, and 3, and then levels 4, 5, and 6. So we actually have 5 deliveries. The 9 zones comes across 5 deliveries. If you imagine the first half is levels 1, 2, and 3, and the second half is levels 4, 5, and 6. We have around 40,000 square meters of deck coming, so and it's important to build the building up as we go. The logistics is, very, very complicated because we're trying to maximize what we bring in a container. I'm trying to sequence a very quick production cycle from Stora with a slightly slower production time from VHAG. VHAG are also pre-installing the connectors in the factory for us. We're using the Pitzel, the Sherpa type connector, proprietary connection system. So they install them in the factory. So that's another activity for them. When the glulam comes to site, we've actually got to install the shoes, wrap the glulam, and there are some elements we're applying a permanent UV coating to, whereas the CLT can come straight to site. So, we have the overall site program, and working back from the installation program, we have a sub-assembly program, we then have a shipping program, and we have a delivery program as well. So we've got a number of programs, all kind of happening at the same time. Excuse me. For the material, we have approximately, as you say, we didn't know that COVID was going to strike. So the building is split into 5 deliveries. We have the first 2 deliveries in Singapore, which started arriving before COVID. As COVID hit, materials were on the water. So they are still arriving. I think the last shipment arrives next week. And that will be the first 2 deliveries. That will be circa 4,000 cube out of the 15,000 cube we're expecting. So we've got a lot of timber sitting in 2 factories in Singapore. Stora Enzo, we're quite fortunate where they were located. They went back to kind of a 3.5-day week. So, kind of 60% production output and kept going. VHAG were unfortunately stuck with a bit of a lockdown for about 5 weeks. And since then they have had, they're back to about 80% as well. Of course, one of our partners in the UK on the structural design, they have also been furloughed and some of their staff ceased working and the rest of their staff were on approximately 70 or 80% time as well. The biggest effect for us, Adam, is actually on the construction site. In effect, Singapore ceased work round about the 1st of April. So we stopped building the concrete cores for the building round about the 1st of April. We haven't yet got permission to start again on site. We're hoping to start sometime in August. And by the time we finish the concrete cores, it would then mean we have timber being installed possibly early October, middle of October. So we've had whilst we were gearing up to install within around 2 weeks' time, way back the end of March, we've actually not installed any timber on site. So yes, you're correct. It is a 4 or 5 month period we didn't envisage and certainly didn't cost for. The challenge from a logistical point of view is we obviously have all the containers arriving in the sequence that we want to erect them on site. So container 1 is the first container I have on site. However, container 1 is now the first container I have at my logistical factory, and of course then container 2 goes in front of it and container 3. So we've had a lot of double handling and a lot of shuffling about of all the chess pieces. We are very fortunate, our group that we work for, Chongqing, they have a logistical company, PTC. It's about a 55,000 square metre logistical centre not far from the site. So we have everything stored there. They've got lots of overhead cranes. They've got lots of space. So we're juggling the chess pieces around there at the moment to try and keep everything in the right order. But very, very challenging, very challenging.
Fighting off exotics and foreign creatures, bugs and stuff.
One of the other challenges I'd imagine during construction is managing moisture. And you mentioned earlier that you're going to have some externally exposed timber. So, and Singapore, I'd imagine, would have some pretty wild weather at times. So, what's the plan for managing the moisture side of things?
Perhaps David could touch on the applications we're doing in the factory, and then I could touch on what we're doing at site.
Yeah, so Gary can talk about the site things, but yeah, the external facade is basically made up of CLT. So CLT with a latch, so it's a 280 7-layer CLT vertical fin with a 220mm latch layers glued on the outside. So that comes from Stora uncoated, and we have to apply a UV coating at PTC, this logistics center. So we can do all that indoors, which is great, and keep it out of the sun and wind. Mm-hmm. And we also have to apply, because it's CRT, we've obviously got an external face that's got an ingrain that we need to protect. So we've got a cover board that we need to glue on. So we can, from like a logistics point of view at the factory and things, we can just take our moisture readings. Everything's coming out of the container pretty well. We've got a little app that we can monitor moisture with that we have to do for our consultants. So from that side of things, it's not too bad. Our internal timber comes with the temporary, VP 312 coating. Our glulam, our CLT is uncoated with some termite protection, because termites are quite bad here as they are in Australia. But everything inside only has temporary coatings. Outside we have to apply it ourselves, and luckily we are applying that in a sort of not controlled environment. It's an open-sided factory, but at least we're not having to deal with the weather from that side of view. And then Gary can talk about how we manage the Singapore downpours.
Yes, when we get to site, Adam, we have roughly 4 squads of people working on site doing installation, and we have 2 squads of people following behind doing screws, and 1 squad following behind doing repairs. The procedure we've set up, as David said, there is a temporary coating on all of the glulam, and the glulam also comes with a UV membrane, a wrap on it for the columns and beams that we will install and take off immediately prior to install. We are not using any form of polythene sheeting or tarpaulins on top of the material. Our plan is that we will, after a downpour, we will not have any leading edges left exposed. We have some aluminium flashings we've pressed ourselves, a couple of 100 meters of aluminium flashings. We will have them on every leading edge, just simple nailed down. That will protect that leading edge from the downpour. All the downpipe holes or service penetration holes will be sealed. We're installing temporary outlets, and the screw and fitting off squad in effect become the squeegee brush squad. After every downpour, the squads will head out and start mopping up the water. We also have a series of large 1.5 metre diameter fans, really to blow air across the surface of the CLT after any downpour, so that we can get rid of the moisture. The items externally, the vertical fins will have a UV coating on them before they're installed, so will be protected. And there is a horizontal fin where we're programming with the main contractor that his upstand precast paraquet will be installed quickly, and the flashing will be installed temporarily fairly quickly, so we can protect that thinner horizontal slab. So a number of measures. You're right. It's very hot. It's very humid, and when downpours come, it's a monsoon period. But I think it's very fortunate that downpours come for half an hour and then they leave, or an hour and they leave. And in the wet season, from November to January, it will rain every day around about 3 o'clock for an hour. And we know that, and it will be torrential. But as soon as it finishes, we'll be straight back out on the timber, sweeping up the timber, setting up the fans, and cracking on. We have divided the building into smaller chunks so that as we go up, we can cover very, very quickly what's down below, which will help protect what's down below. So we should hopefully only have that top level that we are protecting. The sequence of the building is such as well that the main contractor has a concrete screed to apply to a significant portion of the CLT floor and the roof, and we are programming things with him so that as soon as we are fitted off and all the screws are in and checked, he can start sporing his screed, and he will actually pour his screed in 2 sections. So for argument's sake, he's got a quick 40mm screed he can apply very, very quickly, which will help protect the surface. And then his final 60mm topping can go on at a later date to suit the finishing. So a number of options, but very, very important to keep an eye on. We also monitor 10% of the elements on a weekly basis for moisture, and we monitor 10% of the beams for deflection on a weekly basis as well, which, as David mentioned, the company we work it for, very tech enabled. We have an app, a QA app called Novade, that we can just add into that we need to do this check. We need a beam reference, which we will scan from the barcode, and we'll put in the number from the laser, and we'll do the same with the moisture.
We've got to do that for five years.
Oh, great. And then that'll be great data as well to understand the movement of the buildings and whatnot, because it's again one of those things because it's uncertain, you might assume a lot more movement than actually happens.
Yes, we have actually proposed to the client some data equipment from Andrew Dunn that he installed similar stuff at the Phoenix Apartments, because this is a very heavy 7-level building, and 7 levels of, given the section sizes we have, will be a significant weight. So we're trying to persuade the client to install a few of these monitoring devices that we can take moisture readings remotely, and we can also check deflection remotely. So that we're thanking Andrew for providing all that information, and hopefully somebody will pay the cash to provide the data for the rest of us.
Yeah, on that that is quite an interesting point about doing the monitoring and sharing the data, because we've got a wee bit of a story behind pre-cambered beams and deflection of beams on this job, and kind of scouting the globe, trying to get information or people's opinions on the service class of beams in a Eurocode context, and how beams will perform in a humid, where I think we're about 85% relative humidity, and our temperature doesn't change a lot between 26 degrees and sort of 34. But when you kind of put your fingers out and try to get some opinion on how beams will deflect, there's not a lot of data for the sort of central climes of the world and how things perform over the long run. A lot of the data is from a European context, cold winters, hot summers. So that will be really interesting and will be good data, especially for the kind of Asian market, to see how things start to perform.
Absolutely. And what are some of the learnings you're going to both take from this project into future projects?
Look, there are a number of lessons learned that we've been collating. Actually, number one on my list is the engagement with the key suppliers as early as possible. Even better if we can get them as part of the same team, and even better if we can get them as a single source. If you have multiple sources, the construction industry has lots of site managers and QSs and project managers and all sorts of people and estimators. We don't have any logistics people in the construction industry. It is a logistical project. We need somebody from the shipping industry or the transport industry. One of the other things to think about, that don't necessarily jump to mind as being part of the team is, David's now dealing with some issues where they've now picked the man that's supplying the ventilation equipment. So we're back to the beginning of, can we hang this here? How much is this weight? How does that pipe get from A to B? I think there's a number of things that should come on. People, I think, would generally think about the facade, but you have to do that list of, let's write down everything that attaches to this timber and let's figure out how we're going to do it. Testing we've already talked about, but get that testing agreed. I think full scale testing, if it's required, just allow for it. Let the client. I'm quite sure the clients don't want any additional cost, but the clients and their advisors a lot of the time leave this blank, and when we have one supplier allows for it and one doesn't, client should bite the bullet and actually say, no, we need the testing, and agree a cost sharing structure for the testing, because it's data for industry, data for the suppliers, data for the project, but ultimately it's all data for the client. So agree that cost structure. One thing we have executed very well for the right purpose was a full-scale mock-up. And when I say a full-scale mock-up, I mean $250,000 worth of material and precast and concrete and a floor slab. It's done exactly what it was supposed to do. It's assisted in figuring out details. Yes, there's stuff not translated through to the final building design, but that's the purpose. Let's not wait till we've got $10 million worth of timber on the water to figure out that something didn't work. Let's do it while the costs are minimal. And the change, yes, there will be change, but let's agree that cost sharing for the mock-up early. We've done lots of small mock-ups, but the large full-scale mock-up, we've done a full bay, we've done a full grid line external of the building, heading in one bay. It has been fantastic. The big thing always misunderstood is the tolerances. It amazes me, we still speak to architects and engineers about the hierarchy of tolerances, and they stare at you with blank faces. When we're pouring a concrete slab and the concrete is allowed to be plus or minus 15, but the base plate is only allowed 15 millimeters of grout, and the timber is plus or minus 1, you don't have to be a rocket science to work out that if the concrete is minus 15 and you want to get to where you are, you're still 15 mil out. That hierarchy of tolerances up and down the building, it's not a blame game. It's actually a let's get all the heads in the room to figure this out. Where we meet the concrete cores, where we meet the steel lift shaft, I can say that, on level 7, we will probably only be 2 or 3 mil out. The precast concrete could be 40 mil out, and they're allowed to be. How are we going to join them together? I think as well, spending a lot of time on that zoning and how are we going to zone them. But when you have such a large building, how are you going to zone it? How are you going to assemble it? Where are your laydown areas? How many tower cranes do you need? How many spider cranes do you need? Are you using the right crane for the job? Can't have enough emphasis. And unfortunately, when we start to head into that construction logistics, you do run into the problem of that competition. and back to the clients want value for money. But if you don't get that logistics right with the design, you're going to end up having significant cost at the end. Always left for somebody to think about later. Temporary works. I'll let David talk about temporary works in a second. The storage and logistics we've already talked about. I think it's always good to go to the end of a job and look back and say, if I knew then what I knew now, what would I do differently? We're trying to capture that as we go. It's part of the remit within Singapore that we have to leave the mass timber industry with some learnings and with a lot more information than they had before we started. In fact, the one other lesson learned that you can't reiterate enough, yes, it's cost, factory visits. Get the team, especially with a new team to timber and a new client to timber. Go to the factory, be it in Albury, Wodonga, or Tasmania, or New Zealand, or Europe. Go look, see the factories, see the setup, see the process, see the logistics, tie it in with some buildings. Everyone will learn a lot from. That's why. That we thought they were being awkward here. That's how the process works. Go and see the factory. Go and see it in real time, if you like. There are probably a couple of things for David to highlight on the temporary works. David, I think that would be useful.
Yeah, our temporary works. So the temporary works strategy for us is basically we've got 8 cores with the building, and our zones mean that we don't have a connected floor plate. So we have these 3 zones that we're working on at once, but unfortunately it means that the floor plate between them is not connected as we go up because we're not building floor by floor by floor. So we've effectively got these 3 isolated little structures that want to flap around a wee bit, and because we've just got, we're just a typical post and beam building with no walls, all columns and beams. We've got only that we just drag all of our force back to the precast. Our vertical fins offer some stability, but they're not like a sort of formal part of the bracing. So that's meant that our props that usually are used, just to sort of plumb a column, are actually, we're having to keep sort of 50% of our columns fully propped for a significant amount of time until we can go up and get everything fully tied back to the cores and start releasing a few props. We've got some interesting sort of gable bracing with props to try and offer a bit of stiffness up at the ends that are far away from the cores. And I guess that, in hindsight, thinking back to how the building was zoned, there could have been some things that were done a little bit easier to try and avoid we have a lot of propping, which is becoming quite a logistical nightmare. And there's a few things that we could have done maybe a little bit smarter and would have affected the way we programmed the job. Things like having on the edge of a zone, some of these, we've got some big open spaces, some triple height columns that are 14.5 meters. Unfortunately, where some of our zones are breaking up, we've ended up with effectively a triple height column that's made of single height, single height, single height. And to try and prop and brace that while you're going up the structure means you've got lower props on the lower beam, then you've got 10-meter props on the next beam, then you've got 14.5-meter props. And trying to deal with 14.5-meter props, that's something that's craned in and out. I think Gary was working the other day on the cost of, being able to use like a simple manhandleable prop versus one of these 14.5-meter behemoths, and it really slows you down and makes it quite tricky.
David, perhaps could you, the other interesting, I think, for everybody would be on, I'm going to say, the document management system or the sharing of models and the working within the model, within the environment, and how, and the importance for all the team to be in the model, not just certain members.
Yeah, so I guess that was something when Gary lured me here, it was one of the things I was quite excited about. I'd heard about Singapore have, as like a government or the BCA here, have a certain level of BIM that you need to adhere to, and it's a really high standard. Unfortunately, our main contractor in this job somehow got a what do you call it, they they basically didn't have to follow it, which is a bit of a shame. And it's meant that through our design phase at the end of last year, it was a lot of 2D markups. It wasn't sort of done in the way that you kind of, when you think of these big projects and this awesome BIM integration, we did not work like that. And it meant that, if you look back at sort of late 2019 for us and the guys over in Europe trying to get this design across the line, just hundreds of pages of markups. You've got a structural engineer giving you a markup that says one thing, signing it off, being like, go for it. Your architect handing you another thing, saying, go for it, and they clash. And then you've got like someone in between, like us trying to coordinate this information together. And it is slow, and you miss things. And that sort of leads to, because from the early outset, that sort of BIM standard wasn't required for it would have helped. Because we didn't follow that, it meant that a lot of our information, we don't really have a strong open source of sharing information, which is a shame for a project of this sort of scale. Like, from an early outset, I guess you need to make sure people have these regular drops, like keep everything open. You want people to know where your panel splits are, like trying to sort out builders work holes, penetrations, without someone knowing where a panel split is. Like, it makes everyone's life really hard. And then leading back to MEP coordination, so mechanical, when we were trying to get this building signed off, the mechanical, electrical, and plumbing just wasn't anywhere near sort of, they were at very, very early stages. And a consequence of that is now we have this material here, beams made, and a frozen set of timber, and now they're trying to run quite heavy piping out, which just simply doesn't work with our beams. We've got shallow service lane beams that just can't take the weight that they're supposed to do. So it's, yeah, we wouldn't be a shining example of BIM, unfortunately, in this job. And like in the sort of next, in terms of learnings for the next project, it would be something I'm like quite excited to be on a project that is like a open sharing of information, like regular drops, like keep everything out there, nothing's hidden, especially with as Gary said, consultants and clients that aren't necessarily familiar with timber. The more you can show them about where your notches are, where your joints are, like you just want to know all of that.
Yeah, you're definitely not the first project, and I think there's a lot. All project teams can perhaps take it to another level with BIM. I think it is common that like the engineer builds a model, the architect builds a model, and then sends it to a supplier who builds their own model, and then the builder goes off 2D drawings after all that. So that's something that happens.
Yeah, we're fortunate, Adam, within Chongqing Group, we have a very large BIM team. So we were able, as a subcontractor, we were able to take both the models and create our own environment, and we were able to put the goggles on and walk around that environment and look at details and try and figure stuff out. So we've done a lot ourselves, and with some of the stuff that CAD makers have done for us and some of the stuff that Urban have done for us, we've worked well within our own bubble per se. However, if Oricon, RSP and the main contractor and the client had been in that bubble as well, we would have got on a lot better.
Yeah, sure.
As we wrap it up, I've got a final question. We've mentioned a few different things like consolidating fire testing and having consultant and project teams have more experience. And there's a lot of different areas where there can be improvement over time. And Gary, what are your thoughts on the cost curves of massive timber as a material as we have all these improve in all these different areas simultaneously? What do you think is going to be the impact on competitiveness with the other materials?
Yeah, look, I think the cost competitive is coming down. The costs are coming down. You're starting to see, I think, costs coming down because in a free market there is more competition, which is good. So that will automatically drive costs down. When Australia has CLTP Burnley up and running, Red Stag in New Zealand up and running, all of a sudden we've gone from one manufacturer to 3 or 4 people of a larger size. That will drive costs down. We're also seeing more and more buildings coming along, and we're also seeing more and more larger buildings coming along as well. and that drives the cost down. The standard detailing drives the cost down. So, I would suggest where, depends who you ask, of course. But if we ask the concrete guys, they'll say we're dearer. If you ask a timber person, they'll say we're cheaper. I think the harsh reality is we're still a few percent behind, but I would suggest we're a few percent behind because the material is still misunderstood, and some of the late adopters coming onto the scene are not using the material as efficiently as it should. A quick example, Housing New Zealand, the New Zealand government's social housing arm, Kiangaora, embarked on a CLT 3-story walk-up pilot project that I kicked off with them a number of years ago. Roughly 12 buildings. The cost for the 12th building is vastly different from the cost for the first. And the prerequisite for this was that it had to meet the square metre rate for the traditional build. Granted, we have moved from a full mass timber solution, all walls and all floors, through to a hybrid solution. CLT floors, CLT spine walls, bathroom pods, and closed panel walls. But as I said at the very beginning to you, the client is using the right material in the right place at the right price. And it was XLAM's suggestion to not use CLT in certain places to get the building more efficient and drive the cost down. That's the right advice as a mass timber supplier you should be giving your client. And that has driven the cost down for that building. The minute the client starts to chop and change that material mix, his cost will go up because each material will start to be used inefficiently. So that's a very good example. I think Kiangaora will be releasing some case study information on that to the market quite soon, and that'll be good for it. That'll be good for everybody. The 3-story walk-up is a very popular product in both Australia, New Zealand, and the US. So it continues to be used more and more. I think there are one last point I would make, Adam. There's lots of information out there. It must always amaze you, as it always amazes me, how many people don't engage with wood solutions, or don't engage with woodworks, or don't engage with Trada, or don't engage with Innovatech in New Zealand. There's lots of information out there. In fact, use the information. It's how you learn about the material and how you drive your cost down to become efficient, ultimately. The last point, I think we're coming into an area where that carbon discussion and the carbon topic has possibly been something that just sits to the side, that nobody wants to know about, over to the left, on the shelf getting dusty. However, our TO50 obligations are fast approaching. Every year it becomes closer. That right mix of material will help us achieve that. I have this concept that if we can swap all the floors in a building for timber, it may let you use concrete somewhere else, where concrete is the best material to be used, because you get all that solid mass in all the floors. So got to start thinking about that carbon equation, and what does mass timber let you do elsewhere in the building? Because none of us would profess that 100% timber building is the right building. Mm-hmm. It sits on concrete foundations. It's joined by steel. Has to be the harmonious use of the product. Let's see where that carbon discussion takes us in the uptake of timber in the right place.
100%. Thank you so much. And if people want to find out more about the project and yourselves or SteelTech, where should they go?
If you simple Google NTU ABS, there's a lot of stuff on the internet, on the web, published by university and the consultants involved.
Thanks so much, Gary and David. That was phenomenal.